Hello and welcome. Today we're going to look at some circuit symbols and how they look like in real life. So, firstly, what we'll see is here are some of the common circuits that you need to know and understand inside the science syllabus or physics syllabus. The first one over here is typically what we would call a battery. Okay, a battery is not what we typically would call it today. It is any combination of one or more cells. So this is a cell. When I only have one of those, it's a cell. When I put them together, it forms a battery. A car battery has got 6 individual cells that form a battery. But a normal battery that we call a battery is actually simply a cell. The next symbol over here is the symbol for a resistor. Symbol over here is a special type of symbol. This arrows represents light, so it's a resistor that has something to do with light. We call it the LDR, the light dependent resistor. Okay, so here we have the typical symbol for a light bulb or a bulb. This is the symbol for an ammeter. We've got the symbol for a voltmeter. This is what we would call an electrical fuse. Over here we have a switch, we have a diode here. This one here with a little tail at the bottom is called a thermistor, and the one with a straight line and an arrow is a variable resistor. Now we can see that the resistor, the LDR, the thermistor, and the variable resistor are all types of resistors, and therefore they all have the square this rectangular shape. Okay, so now we're going to look at each one individually. The first one is a cellular battery. Okay, so this little thingy that we call a battery is actually a cell. But if we look at the car battery, we see 1, 2, 3, 4, 5, 6 individual compartments. Each compartment is a cell. You would even see here at the top there are 6 little openings for battery water or battery acid. So these 6 individual cells form a battery. So a car has a battery, but this little thing that we used to call, or commonly known as a cell, is actually a battery is actually called a cell. Okay, so guys, different types of resistors. These are the types of resistors that you'll see that we'll be using. We use resistors in the sense that, or we think that they don't actually build up heat, but in real life they do slightly. But if we speak about a resistor, it looks like this, and you'll see it in a lot of circuits. And if you look at some circuit boards inside of electronics, you'll see a lot of these smaller ones. Now the lines on them tell you how much each resistor has a value, or the value of that resistor. The different colors have different codes. Okay, and then we use those codes to basically label the size of the resistor. Okay, the LDR is a light dependent resistor. So as the light shines on it, okay, the resistance increases. Okay, the more light, the more resistance. Okay, so as the light shines on it, the resistance changes. So this is a component that helps us to make devices that use light as a stimulus, and we can turn it into a current in our circuit. So for example, day-night switches have something like this. Okay, so it's where we use a light to communicate with our circuit. So it's a way of incorporating light into our circuit, or being sensitive to light. Now this is similar to your eyes. Okay, your eyes is receptive to light, and it communicates with your brain. Just like that, the LDR is sensitive to light, and it controls the current that flows through the circuit. Light bulbs, you guys all know, we get our all typical light bulbs. Okay, similar to the one over here. Then we get our fluorescent tubes, all these tubey lights, and then the latest lights that we get is LEDs. Okay, so different type of light bulbs. All of them would use the same symbol. Okay, ammeters, guys, are ammeters used to measure the current. Over here at the top we've got an analog ammeter, and it uses a little needle. Some of them has 3 settings, and then you would have to look at which set of numbers, 3 settings and 3 sets of numbers, and you will have to correspond which setting goes with which set of numbers. The rest of them are all electronic ammeters, so we get a digital reading for it. The analog one is one we'll use in the laboratory most often, and obviously this is a bit more difficult to read, so you need some skill here. Here you just take your reading. Okay, we've got the voltmeter, we've got our digital voltmeter. We also get an analog voltmeter similar to the ammeter that we will use in class. And then we have what we call the multimeter. Now a multimeter, if you look at these numbers on this side, is usually the voltage, and you can even on the other side measure the current. So a multimeter can go measure current and the potential difference of the voltage. So this is a digital one, and then you get an analog voltmeter that's similar to the ammeter. Okay guys, fuses. A fuse is used to protect a circuit. So in your car you typically have circuits like fuses like this. What happens is, as soon as there's too much current, and remember what happens is current increases the moment resistance decreases. So if there's a short circuit, a tremendous amount of current goes through the wire, and that current burns the fuse inside there, preventing the current from flowing and heating up and starting to melt the wires and cause the electrical fire. So fuses break the circuit, and it's similar to circuit breakers that you'll find in your house. The moment there's too much current running through it, the circuit breaker would switch off to prevent an electrical fire, or if someone is being electrocuted, to prevent that person, tries to save that person's life. Okay, so the next type of one that we're going to look at is a diode. We're going to specifically look at a light emitting diode separately. A diode is a component that makes sure that the current only flows in one direction. Okay, so we get direct current, that's anything with battery power, and we get alternating current. And alternating current is what we use for our normal household electricity. Now, a diode works in such a way that if you switch the battery the wrong way around, instead of the current going clockwise, the current might go anti-clockwise. Now, if you look here, if I put the diode symbol like it is here, it allows current to go from the left to the right, but if the current is reversed, it can't go from right to left. Okay, so we call this a LED. It basically makes sure that all the current flows in one direction, and if the current flows in the opposite direction, it blocks the current. Okay, so a normal circuit would work if you switch the cell around, but the moment the diode is there, it will not allow you to. The next one is a light emitting diode. So you can see here in the symbol that the arrows pointing away points at light. Still a diode, it still only allows the current to flow in one direction. So therefore, when the current is flowing through it, the light would shine off. When the current wants to go against it, it blocks it and no light is shining. What they typically do is, in a circuit, they put 2 diodes. So in a typical circuit, you will have sometimes 2 diodes, 2 light emitting diodes. If you go from A, so okay, light emitting means it shines light, okay, if the current flows through it. So if the current goes from A to B, the red one would block the current, but the blue one would allow the current to go through, and we'll have a blue LED shining. Let's make it a green LED so the thing is on. When the current flows from B to A, it can't flow through the blue one, but flows through the red one, and we'll have a red light shining. So that is typically like some char devices. If we are switching it on, normally a green or a blue LED would indicate it's on, but the moment we are recharging the battery, we see a red LED. So the two LEDs show us either that it's working or that it's recharging. Working goes from A to B and recharging goes from B to A. So it's a circuit similar to this one. Okay guys, a switch is a very basic thing. It's obviously like the ones in your house, but also any other button or a on-off switch, anything that switches on. You can see here there's multiple switches at the top, buttons, flip switches, any type of switch that you use to switch on or off the current. Now here's typically something that we just discussed, a switch with a red or a green LED. So it would shine red if it's off and shine green if it's on. Okay, so switches, anything that breaks the circuit. If the switch is open, the circuit is off. And it's very important to know, a lot of languages do not have the word switch on and switch off in their vocabulary. Some languages, especially some of the African languages, but more worldwide, would speak about opening and closing. So I open the light to switch it on and I close the light to switch it off. But this is opposite to how a switch works. When I open the switch, no electricity would flow and the light would be off. When I close the switch, then the electricity would flow and the light would be on. So when I open the switch, there's no electricity. When I close the switch, there is electricity. Okay, next circuit, next one that we'll look at is a thermistor. Now guys, a thermistor is a very special device. Like a LDR is dependent or is an electronic component that is sensitive to light. A thermistor is an electronic component sensitive to temperature. So here is what we use sometimes in our refrigerators, in our kettles, in anywhere where we want the electrical stimulus for temperature. Now typically your tongue can feel temperature and your skin. So your skin and your tongue has similar functionalities to a thermistor. A thermistor measures the temperature and sends a signal to or it basically sends the current through. So when it is cold, the thermistor can block the current, and as it increases in temperature, the current starts flowing. So when it's low temperature, there's a high resistance, and when there's a high temperature, there's a low resistance. So for example, you want to have a heater that switches on automatically. When it's cold outside, when it's normal temperature, there would be no current flowing because the resistance is high. But as it gets colder, you want your heater to switch on automatically, so that we want the resistance to decrease so that the current can increase. Okay, and lastly we get a variable resistor. Now guys, this is anything with a variable setting, from a volume knob to a stove plate setting. And the one that we'll use in the lab is this one here in the bottom right corner, called a rheostat. Okay, and we use this to vary the amount of flow of current. So when it's at the highest setting, okay, think of your stove, highest setting, highest resistance, okay, lowest setting, lowest resistance. Okay, highest setting, we have highest resistance and small current. Lowest setting, we've got lowest resistance and big current. Okay, so the current and the resistance works in opposite directions. I hope that now that you've seen some of these symbols, it makes a bit more sense, and if you look at the circuits from now on, that you would know what the circuit speaks about. I hope you have a nice day. Thank you very much. Goodbye.